My name is Chase Gibson. I'm a technical sales specialist with Mori Microwave, and today I'll be demonstrating how Insight can be used to objectively identify when a cable assembly has degraded and needs to be replaced. If you're an applications engineer like I used to be, you spend most of your time in a lab taking measurements. And anyone that spends that much time taking measurements has at some point encountered the impact of a cable assembly's slow degradation over time. Doesn't sound familiar? Well, let me explain. Cable isn't binary. It doesn't work one day and then stops working the next day. Its degradation is slow. At some point, its performance changes ever so slightly and adds a little error to your measurements. It may be negligible at first, but as the cable continues to degrade, the errors get larger and larger until one day you realize that something doesn't look right. After dedicating time investigating and isolating the problem to the cable, you then get to review the measurement data taken over the past days, weeks, and months to figure out at what point your data was impacted. Therefore, the data you thought was good ends up needing to be repeated. But what if there was a way to objectively identify the cable's degradation and proactively change the cable before it impacts your measurements? How much time would that save you? Well, introducing Insight, the industry's first commercial software suite designed to empower VNA users by revolutionizing the calibration, validation, measurement, and analysis process, taking into account measurement uncertainties and objectively evaluate the performance of a cable assembly and identify when it's time to be replaced.
Let's do a quick demo to show how easy this process is. When you first open Insight, you'll want to click on the Configuration and Settings module to get to the Cable Characterization section. Here, you can set up and characterize your VNA, CalKit, cables, connectors, and probes. With Insight, you can characterize the uncertainty contribution of any component in a measurement setup. To start the cable characterization procedure, simply go into the Cable tab and select Characterize. You then have the choice to begin with cable transmission or cable reflection. I'll just start with characterizing the cable transmission first. Once the characterization menu is open, simply follow the prompts. It's just a matter of calibrating the VNA, connecting a short to the end of a cable, and then moving the cable based on your typical application. Before I begin characterizing the cable for transmission, I'll quickly calibrate my VNA. Once the calibration is finished, you will want to select the number of measurements to run, then as I said before, connect the cable over to the short standard and start the test. Proceed to move the cable the same way you would when setting up for your application. Note that the first measurement will be used as the reference and it is recommended to select this position based on the DUT. This cable movement process will be repeated the number of times you selected in the previous menu. After you complete the characterization, you can then save it to your cables profile to add to the overall uncertainty budget. You will then want to do the same for the cable reflection test, but with a load connected instead of a short. With regards to cable assemblies and their degradation over time, it's usually related to changes in the cable position caused by flexing the cable during calibration and measurement. After all, cables are consumables. Once the process is completed, I'll go ahead and save that file in the database. The uncertainty contribution of a brand new cable would be low when compared with the same cable that has been used and degraded over time. Insight can be used to characterize the uncertainty contribution of a cable and save it for future comparison. Fast forward a few months later and use Insight again to recharacterize the uncertainty contribution and visualize the degradation. The process can be repeated at regular intervals, and once the uncertainty surpasses your threshold, it's time to replace the cable. And that's long before you start seeing the errors and negative consequences from bad measurements. Next, I went ahead and collected data using a good and bad cable characterization file. Let's compare the two. As you can see, degradation of a cable can cause a difference between the two measurement uncertainties. Here, for example, you can objectively tell how it's changed over usage. If the new uncertainty no longer meets your expectations, replace the cable. If it still works within your threshold, keep using it, and test it again periodically so you can proactively replace the cable before it causes any real impact to your measurement data.
Well, that's it. It's that easy. Just characterize the uncertainty of your cables when you first get them, and as you saw, it only takes a few minutes. The next step would be to recharacterize the uncertainty at regular intervals and replace the cable proactively once it no longer meets your expectations. This way, you will prevent the negative impact which comes from using degraded cables and making bad decisions based on unreliable measurement data. For more information or to download your own demonstration copy of Insight, please visit moremw.com. Thanks for tuning in.